Look at something across the room right now. A clock on the wall, a word on a label, the face of someone you love. Is it sharp? Or is there a soft haze around the edges that was not there 5 years ago? Most people with blurry vision do the same thing. They go to an eye doctor, they get a stronger prescription, they buy new glasses. 6 months later, the visual aid prescription requires another update. The corrective lenses become increasingly potent, yet visual clarity continues to shift. Most people with blurry vision do the same thing. They go to an eye doctor, they get a stronger prescription, they buy new glasses. And the reason your vision keeps deteriorating, the actual biological reason, has almost nothing to do with your eyes. It has everything to do with what is happening in your blood right now while you read this. You have probably heard the word diabetes mentioned in connection with vision loss, but here is what that conversation almost never includes. You do not need to be diabetic for blood sugar to be destroying your eyesight. A formal assessment isn't always necessary, nor are specific laboratory findings. What's often needed is something far more nuanced and widely experienced. You need blood sugar that spikes and crashes throughout the day, and that runs slightly too high, that chronically floods certain tissues with glucose while leaving others starved. That pattern, which research suggests affects the majority of Americans over 55, quietly damages the most metabolically vulnerable tissue in your entire body, your eyes. The retina, the thin sheet of light-sensitive tissue at the back of your eye, has the highest metabolic demand of any tissue in the human body. Gram for gram, it consumes more oxygen and more glucose than your brain. It is extraordinarily active and extraordinarily sensitive. And when the glucose supply becomes dysregulated, the retina pays the first price. There is no billing code for explaining this at a standard eye appointment. The optometrist's job is to measure refraction and fit your lens. Nobody in that system is going to sit with you and that is exactly what this video exists for. Before we go any further, I need to name the symptoms that mean you stop watching and call a doctor today. Not tomorrow, today. Sudden vision loss in one eye that came on in hours or days. A curtain or shadow moving across your visual field. A sudden flood of new floaters, dozens of dark spots or strings appearing at once where there were none before. Flashing lights in your peripheral vision that come and go repeatedly. Any one of those signs points to acute retinal damage or detachment. These are emergencies. No protocol applies to those situations. If none of those apply to you, if what you have is gradual blurring, difficulty reading fine print that has worsened over months, let us start with something that happens to almost everyone with variable blood sugar and that almost nobody has ever had properly explained to them. Your eye's lens, the transparent structure that sits just behind your pupil and focuses light onto the retina, is made almost entirely of. It cannot receive nutrients from circulation the way your organs do. Instead, it absorbs glucose directly from the fluid that surrounds it. When blood glucose rises rapidly after a meal, the glucose concentration in that surrounding fluid rises with it. Here is the problem. Sorbitol cannot leave the lens. It has no exit route. It accumulates inside, and because it is osmotically active, meaning it pulls water toward itself, the way a dry sponge draws moisture, a swollen lens cannot focus correctly. The focal point shifts. Things that were sharp become soft. Print that you could read in good light becomes a blur. It accumulates inside, and because it is osmotically active, meaning it pulls water toward itself, the way a dry sponge draws moisture, and it explains something that confuses millions of people. Why vision is noticeably worse some days than others? Why it is sharper in the morning before eating than in the late afternoon? Why a prescription from 6 months ago suddenly feels wrong? Your vision is not randomly changing. Your lens is inflating and deflating based on your blood sugar. The second mechanism is slower, more silent, and ultimately more destructive. The retina is fed by the smallest blood vessels in the human body, capillaries so fine that red blood cells pass through them single file. Without them, the photoreceptors, the 130 million cells in your retina that convert light into the signal your brain reads as vision, chronically elevated blood sugar damages these capillaries through a process called glycation. Glycation is what happens when glucose molecules. Think of this way. Your capillary walls are built from flexible proteins. They are designed to expand and contract. When glucose glycates those proteins, the walls stiffen and thicken. Like a rubber hose that very slowly turns to ceramic, when the capillaries feeding your retina begin to leak, Fluid and blood seep into the surrounding tissue. The retina swells. Visual signals become distorted. This is the beginning of what clinicians call diabetic retinopathy. But the underlying process, capillary glycation, begins years. You do not need a diabetes diagnosis for this to be happening. You need cumulative glycation exposure. And cumulative glycation exposure. The third mechanism targets a different part of your eye. And this one is most directly connected to what you eat. Reading, recognizing faces, seeing fine print. The macula has the highest concentration of cone photoreceptors in the eye. The macula contains two carotenoid pigments, lutein and zeaxanthin, that act as its primary defense against oxidative damage. These pigments absorb blue and ultraviolet light before it can reach and damage the delicate photoreceptors underneath. They are the macula's built-in internal filter. Chronic blood sugar dysregulation floods retinal tissue with oxidative stress, an overproduction of chemically reactive molecules called free radicals that damage cell structures. Lutein and zeaxanthin are consumed in neutralizing those free radicals. They are depleted faster than the body can replenish them. And when the macula's protective pigment runs low, light reaches the photoreceptors unfiltered. Damage accumulates. Visual acuity falls. Most people over 60 are already low in these pigments because their diets are low in dark green leafy vegetables. The fourth mechanism connects your vision to something you probably think of as entirely unrelated: your kidneys. The eye and the kidney share an important biological feature. Both are heavily supplied by a particular type of tiny vessel that is uniquely vulnerable to glycation damage. This is why in people with long-standing blood sugar dysregulation, kidney function and retinal function tend to decline together. But the connection goes further. When kidney function begins to decline, a cascade follows. Fluid retention increases. Elevated intraocular pressure is the primary driver of glaucoma, the condition that progressively destroys the optic nerve. Glaucoma produces no pain. But the connection goes further. When kidney function begins to decline, a cascade follows. Fluid retention increases. It is connected. The mechanism flows in one direction: blood sugar first and vision loss downstream. Consider someone else. She went to her optometrist twice in 3 years, and both times came away with a stronger prescription. Eleanor was told to eat more leafy greens and wear good sunglasses. She did both. The vision kept getting worse. The blurring was worse in the late afternoon. It was noticeably better in the morning before eating. After a larger dinner, pasta, bread, something sweet for... After a day of eating mostly protein and vegetables, her vision was measurably clearer. She had not connected those observations because her fasting glucose was 102, not diabetic, not even pre-diabetic by most clinical definitions, a number that generates